Hello and welcome to week 3 of this lab on this course on big data. In this week, we will discuss about the different types of data and how that plays a critical role when you embark on your big data project. I'm your instructor. My name is Rangarajan Vasudevan. So let's start with an analysis of what are the different types of data sources. So while the subject could be vast and complex, and it could seem as though there are so many different varieties of data sets and where they come from, really, if you look at it, in a typical enterprise, in a typical company, you really have only 4 different types of data sources. And those data sources in turn dictate the types of data formats that are possible and the nature of processing that you will have to do on top of it. So before we get further into this subject, it's important to understand why does it matter to understand what the types of data are. So what is commonly done in data science courses is for the project in such courses to start with a highly prepared data set. What I mean by that is the data set is already formatted, prepared, in many cases cleaned up and structured neatly in the form of independent variables and dependent variables. So you can think of it as an Excel spreadsheet of data sets. And it's usually starting with that particular legwork that's already done, and then the coursework moves on to trying to create a data science solution to a particular problem statement, like for instance building a model, etc. But in reality, you would find that the effort required in creating that cleaned, prepared data set that's possible for data science algorithms to work on top of is itself a significant effort. And in fact, in many projects that happen in real world, data engineering is actually a critical activity, and it's a prerequisite to being able to do data science. And in fact, in most scenarios which are practical, the volume of data is so large that you would have to do data engineering in the big data domain. And that's why it's important to understand what are the different types of data, where do they come from, what is the source system assuming when it creates data of a certain kind, and what do we need to therefore take into account when we build our data engineering pipelines. Do we need to take care of those assumptions in a certain way? Do we have to factor in additional steps involved in our processing because of those assumptions, because of the ways in which data is collected? All of those become questions that the data engineer needs to answer, and that is the main motivation, really. Okay, so let's take a look at the types of data now. The first is what's called as database backends. I've just abbreviated database as DB. Here, database could refer to the classical relational database management systems, or what is abbreviated as RDBMS, or it could also be the new age NoSQL data systems. So those could also be valid backends that you might see in the real world. Nevertheless, it doesn't matter whether it's NoSQL or RDBMS. The DB, the database backend itself, is the storehouse of the data, and therefore that becomes one of your sources. The second type of data source that's possible would be API endpoints. So here, a source system exposes an API which allows the data consumer to request for data of a certain kind. And the kind of data that you can request is restricted to what the API supports in its request response contract. And whatever is the response format that it supports is exactly what you're going to get as the format of the data. Invariably, APIs in the modern world are either REST-based or WebSockets-based. So you would find it's the data format is typically going to be JSON or XML, and those in turn need to be structured in a certain way so that the API contract is honored. What I mean by that is, if you make a request for a certain type of data, the API endpoint that you're querying will have to return data which adheres to a certain guarantee. Like one of the guarantees would be the response follows a certain metadata format, right? It has a certain payload, the payload has certain fields, the fields have a certain data types, and there is a certain structure to all of this. So those become basically the format in which the data becomes available to you. Then the third type of data source is what's called as a message store, or messages in short, or streams. So here, messages refers to data that's individually available to you, item by item. So you don't have to query for the entire table, which is what you would do in a database. And even if you wanted a specific row or specific item, you would still go and touch the entire table, right? So that's optimized for what we could think of as batch data extraction. But messages, on the other hand, allow you to get to individual items of data at the most raw granularity, right? Without having to necessarily query all the messages at all times. That's why it's also called as streams, because a stream, as you can visualize, it's a body of water that continuously flows. So unless you artificially put a barrier like a big rock or a dam, the stream never stops, right? That's the way we imagine what a stream looks like. So likewise, a message stream or a data stream continuously flows. So you get item by item, you get per data record going through at any point in time, and none of it is stopping for you to consume. If you're ready to consume, you can just go dip your consumer into that data stream and collect whatever data you want, but the data stream continues to move on, right, for the rest of the consumers who are downstream. So that's the visual that you can keep in mind when you think about streaming data, when you think about messages. And we'll come back to this topic in a later lecture, because in the real world, again, especially with big data and cloud, almost any modern day successful application that you see, which is consumer facing, like a B2C app, like Swiggy, IRCTC, etc., Ola, they all deal with message streams fundamentally as the data exchange format. So this is going to be an important concept to understand anyway. Right, so that's data source number 3. Moving on, the data source number 4 is batch files. And that's how we all understand data, right? When we do those data science projects, we get the data available to us in a batch file, like a CSV file or a compressed file, etc. But nevertheless, it's all batch files of data. When we get an Excel sheet, it's again a batch file of data. When we get an email attachment, that's again a batch file of data. So we are most commonly interacting with datasets as batch files. Note that I could have just called it files and we would still have the same understanding, but it's more accurate to call it batch files, because fundamentally the files way of storing and retrieving data, which is basically a collection of data at any point in time, is more optimized towards batch execution, meaning it is not conducive for real-time execution. So if you needed real-time execution, you would potentially use messages and streams as your preferred data source format, and in some cases you could also work with data sources which provide APIs, because you could in real time invoke an API and consume the data that's available at that particular point in time. Database backends are not very conducive to real-time extraction, and what I mean by that is you cannot go and query the database backend every millisecond or every second and expect to get the most recent data. firstly, it will be extremely cost-wise prohibitive, and secondly, many databases have inherent latencies associated with preparing and planning queries and select statements. And even if you pre-plan and store the plan and use what's called as prepared statements, it still takes a bit of time to execute the prepared statement to get the data that you want. And more often than not, the database is optimized towards a certain workload, and that workload is typically not the workload that you would impose on it when you want to extract data from the database backend in real time. So yeah, long story short, all of these formats are conducive for batch, and format number 3, or rather all of these types are conducive for batch, and type number 3 and type number 2 to a lesser extent are more conducive for real time. Alright, so that's the discussion on data sources and the types of data sources. Now, who produces data? Let's ask this question. And it might seem like a very obvious question, but the reason why the question is important is it automatically sets a set of questions as corollary questions that you need to answer. And this becomes important for the designer who's actually building the data engineering pipeline. Again, if we go back to our projects where we have done pure data science, maybe as part of a data science certification program, we don't pay attention to these questions. And then as a result, the problems associated with cleaning data, the problems associated with processing data seem insurmountable, right? Seem very challenging and complex. But if you just take a step back and think about how the data gets produced, how the data gets formatted in that particular manner, then things start to fall in place in your head, right? As to how to reason about it, how to attack that particular problem of processing and massaging the data to make it ready for analytics. So coming back to the question, who produces data? And in the modern world, right, I'm talking about last like 15, 20 years, it's been predominantly software that produces data, as opposed to humans producing data. Right? So that's the distinction I'm trying to draw here. And the moment you realize that software produces data, right, then you start to realize the way the software is created actually has a direct impact as to how the data gets captured and how the data gets produced. So naturally, you could have the realistic expectation that the designer keeps in mind that data needs to be captured in a certain way, and then they design those data captures appropriately, which would be true, right? Most software applications, if not all, are designed to keep in mind certain ways of storing data. But what is not kept in mind when the software gets designed is who will need to read this data at a later point in time for analytics. Meaning, in other words, software is designed for a certain functional end use, and that functional end use is related to a business problem that is getting solved immediately by that software. It is very rarely designed for somebody else at a later point in time to analyze the data that the software produces, to go back and improve either the business process that the software is attacking, or at least the software to make it better. Right? So this use of analytics happening at a later point in time is never thought about upfront. And that's been the case for software that's been designed for the last like 30, 40 years. It's definitely been the case for software that was designed like 20 years, 15 years ago. But of late, the movement towards cloud native has also brought into focus what is the level of observability I need in my software, and therefore what is the data exhaust that I need to produce as part of my software, so that people who are looking to analyze this at a later point in time can more easily tackle that problem, can more easily grab that data and do whatever they want with it. So the observability motivation has made the software designers more aware that data needs to be produced as an exhaust. Again, the word exhaust is useful as a visual imagery. So think of any machine, let's say the combustion engine that's in your car or in your bike, and as it moves, it's producing exhaust, right? And the exhaust is all pollution, is how we think about it. But in the world of software, the data that gets produced as trail of how the software is working, including the datasets that are provided by the users of the software, right? All that forms the data exhaust, and that data exhaust is extremely valuable for the analyst to go and analyze and figure out what improvements it can make. All right, software produces data of all four types, right? So many software applications are designed with database as the backends. Some software, especially those which are modern internet-born software, are designed with API endpoints in mind, both for querying as well as for accepting inputs. A lot of software is real-time in nature, meaning it's meant for accepting data interactively within milliseconds, and also a lot of it is meant to return responses in real time. So in those cases, the software is well used to thinking about storing and retrieving data from message streams. And then finally, software produces batch files. That's also very common across the enterprise. What about manual though? I would think that manual is actually something that is dwindling as origin of data. It's still there, it's still present in some verticals, some sectors like manufacturing as an example, where somebody's physically going and auditing a piece of equipment on the factory floor. Then they make some entries in a notepad or in a standard form. But even that is getting digitized as we speak, right? In fact, I think digital transformation, which is such a buzzword, is there omnipresent across all sectors that we typically have in our real world. And therefore, almost all points of manual labor is getting digitized in some shape or form. Either the point of entry of the data itself is digitized by means of an application or a smart device or a smartphone, or even a call recording or a form entry, etc. Or even if that data is getting captured manually in a notebook, there are mechanisms available that can take that data and digitize that. An example being a very popular category of tools called as OCR, right? Optical character recognition. And its more advanced deep learning cousin, which is geared towards reading handwriting, right? So these sets of tools have made it extremely easy nowadays for machines to go read notebooks of human entered data, right? Be it in plain cursive writing or could be in block print, etc. Right? So that's also possible nowadays. Anyway, manual data sources are typically going to be batch files. Very rarely, and in fact, if not, I can't think of a single real-world example where manual real-time data is being generated. Right? That doesn't seem feasible. Obviously, human entries into database backends are possible, but not that common. It's more common that humans are creating batch files, like for instance Excel sheets and passing it around in emails, etc. Alright, so with that, I'll stop this particular video. In the next video, we'll take a look at more details about how these data sources need to be processed.